Hey guys, so we're shut down again. I wanted to talk to you guys, finish this section. First thing I want to make sure you guys understand with these periodic functions. So periodic functions, again, functions that repeat themselves, right? Any function that will repeat, that's going to be a periodic function. The period, that's going to be the length of one cycle. Cycle is going to be the pattern that repeats, okay? So, for example, this is a repeating pattern, right? Like there's definitely a pattern that's going on here. The cycle would be the one part of this that would repeat. So, if this pattern is what's repeating, then when we duplicate that, that's one cycle, right? And then the period length is going to be the length of one cycle, so from 0 to 4. Now again, keep in mind that period length, there is no one cycle for one of these, meaning this could also be a pattern. You know, if I start here and I go down first, right? And then it would end here. So this could also be a cycle, right? This set of 4 could be a cycle, or this set of 4 could be a cycle. Any length where it repeats, that's a 4, any length from where you start to where you finish, that could be considered one cycle. And now again, with these, one easy way to tell where a cycle begins and where it would end is look for one key spot, and then it also has to end in the exact same spot. So if it starts at 0 here, it's got to end at 0. Up here, if you want to consider this a starting point, the peak, well then when is it at that peak again? If it starts at 2, it's got to end at 2, kind of thing. All right? So with those periodic functions. So another thing we've already talked about is symmetry. There's 3 types of symmetry. There's x-axis symmetry, there's y-axis symmetry, and there's origin symmetry. With x-axis symmetry, yep, again, we're reflecting across the x-axis, right? The y-axis symmetry, we would reflect across the y-axis. And then the origin symmetry, remember, we are reflecting across the origin. The easiest way to tell if it's origin symmetry, look for one point. Let's say the point of this point right here is back 2 up 4. So this is at the point -2, +4. Well then this point down here would have to be at +2, -4. Okay? So it's getting on the opposite side of the origin. Okay, now there's those three types of symmetry. Now the next thing we have to talk about are 2 different types of actual functions. There are what we call even functions, and we have odd functions. Okay? Now the formal definition of what an even function is if you have f of -x, okay, that's going to also equal f of +x. Okay? So, what that actually means, if you were to plot some points, okay? If you were to plug in, let's say, a 2 and you get a 5 out, and you plug in a 3 and you get a 7, you plug in a 4 and you get a -2, right? Well, what this means is if you plug in the opposite of x, you're going to get the same thing you got when you got +x. So what that means is if I had plugged in a 2 and I got a 5, well now if I plug in a -2, I'm going to get the same thing. I'm going to get 5 again. If I plug in a -3, that means I'm going to get the exact same thing I got before. And if I plug in a -4, I get the exact same thing I got before. Simple enough? Now, graphically, what happens here, and I'll just do even on this one screen, Okay, so we'll talk about odd here in a second. Oh, come on, erase. So graphically, what ends up happening is if I have a point at 2, 1, 2, 3, 4, 5, so I have a point 2, 5, I had a point 3, 7, and I had a point 4, negative 2, right? And then when I plugged in the opposite points, when I plugged in the negative 2, I got a 5 again. When I plugged in a negative 3, I got a 7. And when I plugged in a negative 4, I got the negative 2 again. Now the question becomes, what type of symmetry is this? Well, those points, this is going to have y-axis symmetry. So an easy way to tell what type of function something is actually by the symmetry. If you ever see y-axis symmetry, you know it has to be an even function. Okay? Now, odd functions are kind of the opposite of that. What happens is when you plug in the opposite of a value, you don't get the exact same thing you got before when you plugged in the regular version. You get the opposite of that. So what that means, when we plot some points, you know, if you plug in a 2 and a 5, you get a 5. You plug in a 3 and you get that 7. You plug in a 4 and you get that negative 2. Well, now, when we plug in a negative 2, we're not going to get the same thing we got when we got positive 2. We're going to get the opposite of that. So we're going to now get negative 5. When you plug in a negative 3, now we get a negative 7. When you plug in that negative 4, now we get the opposite of that, which is going to be a positive 2. Okay? So graphically, what ends up happening, now we plug in the 2, 1, 2, 3, 4, 5, we get that point. And then we had a 3 and we plug in a 7. We plug in the 4 and we had the negative 2, right? Oops, come on. Don't do this to me. Quit doing that. Come on. All right. Right? We're down here. So there's our points. Well, now, when we plug in that negative 2, we don't get the 5, we get the negative 5, right? So this point now comes down here. That 3, 7 now becomes 3, negative 7. And that negative, and that 4, negative 2, negative 4 now becomes positive 2. So this point moved down here, this point moved down here, and this point moves over there. That is what we call origin symmetry. So basically, one easy way to tell is if you see y-axis symmetry, that means it has to be an even function. If you see origin symmetry, that means it has to be an odd function. Okay? I always remember that the O's go together. Origin means odd. And this actually goes both ways. If you know you have an even function, that also means you know you have y-axis symmetry. And likewise, if you have an odd function, then you know you have to have origin symmetry as well. Now, you might ask, what about x-axis symmetry? If you see x-axis symmetry, come on, pen, work. Well, if we just take an example, x-axis symmetry, right? Well, that means if I have something that looks like this, well then x-axis symmetry, it has to look like that, right? Well, what type of function is this? Well, that's going to fail the vertical line test. It's not a function. which means we're not even going to have to worry about it. So y-axis symmetry means it's an even function. Origin symmetry means it's an odd function. X-axis symmetry is not a function because it's always going to fail the vertical line test. So x-axis symmetry is not as important to us as y-axis and origin symmetry. Okay? So, if you take a look at page 63. Now on page 63, and I'll pause for just a second to let you get there. On page 63, I want you looking at some classroom exercises. Okay? Pause if you need time to get open to page 63. So now that you're on page 63, if you're looking at number 1, classroom exercises, the question is that going to be a periodic function? The answer is yes, that's repeating. Okay, that's a repeating function. Number 2 is not going to be a repeating function. Okay, even though it's not going to be a periodic. Even though it looks kind of like it's repeating, where it's going something like this, and it's got that, there's definitely a pattern there. This is not going to be a periodic function because the pattern itself is increasing. That can't happen, so that's not going to be periodic. Number 3, yes, that would be periodic. Okay, and number 4, no, that is not periodic. Okay, so it's not repeating. And then number 5, now they're talking about what type of symmetry. Number 5, that would be y-axis symmetry. Number 6 would be origin symmetry. Number 7 would actually be all 3. It would be y-axis symmetry because it's symmetrical across the y-axis. X-axis symmetry. Okay, so our pattern that we're looking at looks like this. Okay, that definitely has x-axis symmetry. It also has y-axis symmetry, but it also has origin symmetry. Because if you take a point here, that point would move down here, and this point here, okay, would move down here, and that point here would move across the origin over there. Okay? And then again, for number 9, 10, 11, 12, we can tell is it odd, even, or neither based simply on the symmetry involved. So number 9, that's origin symmetry, which means that's an odd function. Number 10, that's x-axis symmetry. So x-axis symmetry, not a function. Number 11, there's no symmetry at all there, so that would be neither. In number 12, that's y-axis symmetry, so y-axis symmetry is even. Simple enough? Now if you turn the page and you look at the next page, the first few problems I think you shouldn't have too much problem with. 1 through 6, again, that's just, is it a function? Is it periodic? If it is periodic, what's the period? I think you guys should handle that pretty well. The answer to number 1, yes, that is a function because it passes the vertical line test. Number 2, yes, it's periodic. And then if you look at the length of one period, so if it starts and then where does it end again at the same spot, I would say the period is 2. Okay? Now, number 7. So what number 7 is asking us to do is basically to keep that pattern going. They give us this drawing looks something like that, right? And now that's at 2. And basically what they want us to do is draw it from 0 to 8. Well, if that length is 2, here's 4, here's, I hate it when this pen does this. Here's 6, and here's 8. And all you have to do is keep that pattern going. So they would have to do something like that, and then make another one, and then make another one. Just keep that pattern going. Now, when you get to 13, there's a couple different ways you can do those. Okay, on number 13, where it says 2x squared, you can do this based on the graph. You can graph these and look at the symmetry involved. But another way to tell these is just simply to look at the exponents. That exponent is even. That means this is going to end up being an even function. Now the idea you can do this is basically you have to look at all the exponents. In number 14, the only exponent there is a 3, which means that is an odd function. Number 15, where it says f of x equals x. Well, x is the same thing as x to the first power. That would be an odd number, so that would be an odd function. Now, if it adds a constant, so let's say I give you something like this. F of x equals 7x squared plus 5. This number here, that 5, you also got to think, isn't that the same thing as 5? Why is this doing this? 5 times x to the 0, right? Now, officially, 0 is not an even or an odd number. I want to make that clear. But if you had to name it, and you said 3 is an odd number, and 2 is an even number, and 1 is an odd number, we have 0, we have -1, we're going to say that's definitely an odd number, -2 is an even number, right? If this pattern were to continue, I mean, I know 0 is not technically an odd or an even number, but if you had to give it a value, wouldn't you say it's an even number? So in this case, actually, we can consider 0 an even number, and it does work out to where, since both of these exponents are even, this would be an even function, okay? If it said something like f of x is equal to 4x to the third plus 5, well, now that 5, again, is the same thing as x to the 0 power, because that'd be 1. I have an odd and an even. This would be neither. If all your exponents are even, it's an even function. If all of your exponents are odd, it'll end up being an odd function. If you have some odd and some even, neither. Make sense? Let me know if you have any questions on those. The rest of this is just going to be symmetry, okay? I don't think you'll have any problem with those. When you get to 31, okay? Now, on number 31, what you have to do is you have to draw that shape 3 times, okay? Come on, work. Oh, now you're going to work. Okay. Whoa. What is going on with this pen? Stop it. Okay. So you have to draw that 3 times. Come on, pen. I know you can do this. Copy, paste. There we go. Okay. Now we got that out of the way. So what you have to do is you have to draw it 3 times. Once with y-axis symmetry. Well, y-axis symmetry would look like that, across the y-axis. And then you have to draw it with x-axis symmetry, which would mean this would get reflected down there. And then you have to have origin symmetry. This pen, sometimes. Okay, origin symmetry would get reflected down there. Easy enough? Now, yes, I'm going to make you draw it 3 different times, because if you put all these on one drawing, you're not going to be able to tell which one goes with which. So please draw it 3 times. When you do number 37, okay, you do not have to draw I'm going to only make you do the evens on this page, but I do want you to do number 37. You don't have to draw 31, 33, and 35, but you do have to visualize them. Because the question is, which of those, out of all of those, there's 6 problems, 3 drawings for each one. Out of those 18 different drawings you would do, which ones would be a function, pass the vertical line test, and which ones would not. So in 31, yes, that would pass the vertical line test. No, that would not pass the vertical line test. And yes, that would pass the vertical line test. Fair enough? Please let me know if you have any questions. I will talk to you guys later. Hopefully the computer works a little bit better tomorrow. See ya.